but you're not going to come up with anything relevant. It's basically saying that anywhere your hypotenuse or your law of sines and law of cosines is going to work because you don't have a 90-degree angle, that's where the cosine and the sine. You can also say, let me just put it to you this way. Where did my little thing go down here? Did y'all see it? It disappeared. Oh my gosh. My whiteboard disappeared. Damn Ukrainians. Oh, I said Ukrainians. I'm going to get an email and YouTube.
You're not going to make any money from this video.
I know. It's awful. I don't know what happened to my whiteboard. It just disappeared.
He gets money?
Probably.
No.
No, I don't get money.
I
have millions of people trying to learn how to do math. I wish that were true. Then China and Japan wouldn't be kicking our butts. We had more people with the work ethic of China and Japan, we'd be number one in everything. But that's all right. Bernie's gonna take care of all of us. Yeah, he is. Bernie gonna pay for everything. Yep. All right, this is what I was going to show you in a roundabout way. Remember me telling you that physics, to find the y, is going to be r sine theta and r cosine theta? Well, basically, whenever you have a triangle, your adjacent is going to be like cosine theta. And your opposite is going to be sine theta. So, if I want to find something, then I have to put it in relation to cosine sine. See what I'm saying? So this is your x, and this is your what? Your y. We're going to get into this later with the vectors and the polar coordinates. We're going to get into this later. But they're introducing it now when we get into the sum and difference formulas, which basically means something like this. Okay? And that's what it means. That's why they got the A and the B. They got all this here. That really doesn't help you. So I'm going to move on. Okay, there's one. All right, there is the difference formula right there at the bottom. You don't have to write all of that because that's how you get it. But cosine A minus B, write that down, is equal to, and I'll highlight this in red, meaning that it's very important. And all of them are based off of the Pythagorean theorem. As you know, you can't have trigonometry without the Pythagorean theorem. So most of your trig identities are going to spin off of the Pythagorean theorem. And we all know how to pronounce it now correctly. Pythagorean. You're going to have a sum and you're going to have a difference. And there's about 4 or 6 of them. All right? So remember, minus, what's the opposite of minus? Plus. Just remember, cosine, cosine, sine, sine. And then remember the opposite of negative is cosine is here, so cosine comes first. Distribute, cosine A, cosine B. Cosine A, cosine B, and then what's the cofunction, what's the function before cosine is the sine. So that's, there's several different ways you can try to remember it. If you want to try to remember the derivation, go knock yourself out. But we're not going to do that. So when you have cosine A plus B, that's the same thing as cosine of A minus B. So therefore, cosine of A plus B is going to be, what's the opposite of plus? Minus, cosine, cosine, sine, sine. Now that's your first two. So write those down if you haven't written them down already. Now, what do I mean cosine? Well, let's say I give you the cosine of 75 degrees. What can you rewrite 75 as?
30 plus 45.
Yeah, I appreciate the interaction.
30 plus 45.
Thank you. It's always nice to have somebody. Now, I hope they didn't come to Pendleton. They're going to get mad at him for talking. So, if I gave you the cosine of 75 degrees, you need to think in respect of the special what? Special angles, Hubert. That's right, class. So that would be the cosine of what? 45 plus 30. There's your two special angles. And you would use that. Now, you could do it by the calculator, or you could do it by your radicals. They're going to ask you to do both with your homework and test. Now, the next set is going to be a little bit different. Okay, they're going to go ahead and tell you to do it. So let's do this one. Cosine of 15. Well, that's going to be 45 minus 30. So the cosine of 45 minus 30 is cosine of 15. So I'm just going to go ahead and do the first step. Cosine of 45 minus 30 is equal to the cosine of 15. Oh, yeah, I forgot to tell you, I went to see Joker.
Was it good?
Loved it. I thought it was a good movie. The acting was so good in it with the main character that you didn't even realize that he was a comic book character. I mean, it was a very... Now, I'm not meaning this in disrespect. I told my son that he wouldn't like it. Why? Because it ain't computer generated and it doesn't have people bouncing bullets off of them and all this stuff, okay? So it doesn't have the crazy... But if you like acting... But I think Hollywood did something they didn't expect. Hollywood, basically, when they did this movie, I don't know if they meant to do this, but they actually amplified the awareness of mental health. You know how everybody says that guns kill people, guns kill people? Guns don't kill people. Don't blame the bombers when they bomb a building. You don't blame the bomb, you blame the bombers. You don't blame the car when a drunk driver kills somebody. So you don't blame the gun, the person. And I think in this movie, it amplified my awareness of mental health. A person that has mental health problems, there's no question there's no reasoning to some of the things they do. So if you're looking for a good movie that's got real deep, in-depth acting, it's a good movie. If you're going because you want to see the Suicide Squad, it's not. That's not what you're going to see. Anybody else seen it?
Mm-mm.
One person.
No.
What?
I'm seeing it tonight.
I think you're going to like it.
If you want to watch my kids, I'll go see it.
Well, I can barely take mine. Okay.
Yeah, you wouldn't like my kids.
And then mine are coming over tonight. I've got my son this week. My daughter's coming up from Clemson. She's coming down to eat. And I'll have them. And by about 30 minutes after they're together, I start drinking. So, all right. So that's pretty simple. Now you're going to do, this is where your radicals come in. Okay? There you go. Write those down. Now, I'm not going to ask you to try to think of them right now, but you know where those come from. Remember, Oscar had a hunk of apple, 45 degrees, 1 square root of 2, okay? And cosine of 30, 1 square root of 3, 2. Y'all remember where they come from? That's why you need to make sure you know what's going on. And then, of course, now it's basic what? Math. So that's going to be the square root of 6 over 2 plus the square root of 2 over 2. I'm sorry, 4. There we go. And that's the square root of 6 plus the square root of 2 over 4. Now, most of your academia questions is going to ask for this. Do you use this in the real world? Hell to the no. Okay? You don't use this is another, take something apart, manipulate it, put it back together. In the real world, you would use what? Calculator. So write that down. That's a good example of a test question. I'm not going to make this difficult. If I get you to acknowledge the identities on this test and actually know how to use them, I will be very happy. I'm not going to try to give you a trick question on the identities. I'm trying to get you to learn them and learn how to use them. Capiche? All right, try that one. First thing I'm going to tell you to do is turn it into what? Degrees. Because you don't know where the hell it is. Unless you're Rain Man and you know what 5 pi over 12 is. So 5 pi over 12 multiplied by what? 180 over pi. And 6 will go in there 30 times, so that's 150. Somebody check my math. No, it's not 150.
75.
Let's see, what did I say? 3 will go in there 4 times. 3 will go in there 60. 4 will go into 4 1 time. 4 will go into 60 15 times. Y'all check me. 15 times 5 is what, 75 degrees? Y'all check me. 75 degrees?
Yes, sir.
All right, then what is 75? 45 plus what?
30.
30. So you're going to plug it into 45 plus 30. Now, do you have to do it 2 pi over 12? No. I'm going to do 40, 35. I'm going to do 40 and 35. So I'm going to go cosine of 40 plus 35, I'm sorry, 45 plus 30. So that's going to be cosine, cosine. So that's going to be cosine of 45, cosine of 30, minus sine of 45, sine of 30. And what is the cosine? Oscar had a hump, so that's going to be 1 or 1 over 1, right? The cosine of 30 is square root of 3 over what? 1? Somebody check me, please. Minus sine, Oscar had sine of 45, Oscar, which is 1, square root of 2. And I'll fix it later, right? No, square root 1 over 2, 1 over 2. Got it mixed up with the 45. Yeah, that's right, square root 2. Square root of 2, and sine of 30 will be 1 over 2. Y'all check me. So that's going to be square root of 3 over 1 minus, let's see, that's going to be square root of 2 over 2 times 1 over 2. So that's going to be square root of 2 over 4. Square root of 2 over 4 minus 4 square root of 3 over 4, which is 4 square root of 3 minus square root of 2 over 4. Somebody check me.
Okay, I'm a little confused. Did you say the sine of 45 was 1 over the square root of 2?
Yeah, did I not do that right?
I feel like something's
So
wrong there, but
well,
I'm
don't
not
we
sure.
have to... Never mind,
Oscar
never mind,
had,
never mind.
that's 1 over
I
square
wasn't
root
paying
of 2.
attention. My bad.
What?
I wasn't paying close enough attention, my bad.
That's fine. I'm just appreciating the interaction with the Pendleton campus. Thank you. Was that Pendleton?
Yes.
Wow. They did talk. Okay. So check and make sure. Let's just see what they got. Because I was doing it in my head. Along with all those crazy other things in my head. Okay, I'm a little bit. I got the negative square root of 2. I got that. So evidently I've got something wrong somewhere.
I think it's your cosines.
Okay,
Cosine
cosine.
of 45 and 30.
Cosine. Oscar had a hunk.
Goodbye.
1. That's it. 1 over the square root of 2. That's it. Cosine of 45 is 1 over the square root of 2.
Okay.
Yeah.
Y'all check me. I told y'all to check me.
What's
Check me.
fine.
We weren't sure.
Sorry. Oh, so. Square root of 3 over square root of 2. So that's going to be, that's the square root of 2. So that's going to be the square
Cosine
root
of 30 is the square root
What?
there of
Square root
2.
of b over 2 is.
What'd you say? Cosine of 30 is square root of 3 over 2. I was doing it in my head, so leave me alone. So that's going to be the square root of 3. So we got to do the square root of 2 over 2 here. Square root of 2 over 2. So that's going to be the square root of 6 over 2. Somebody check that out for me. Square root of 6 over 2. Square root of 6. That'd be 2 square root of 6. I got it. I got the square root of 6. Y'all figure it out. It's in there. I got the square root of, let me just erase it and start over. How about that? I thought I had it. I guess I should follow the slide and that way I won't mess up.
Multiplier denominators.
Okay. The square root,
2 over 2, right?
square root of 3 over 2 here,
2 over?
right there, right?
No, 2 over 2. Square root of 2 over 2.
Yes, you're right. That's 45.
Yeah, so it's
Square root of 2 over 2,
Square
and this is square root of 3 over 2, right?
Yeah.
Okay. Minus, this is sine of 45, square root of 2
Over 2.
over 2, and square root of 3 over 2, right?
1 over 2.
1 over 2. There we go. Now we're good. So that's going to be the square root of 6 over 2 minus the square root of 2 over 2, and
They're over
that's
4.
4. And that's square root of 6 minus square root of 2 over 4. The whole point is, the reason I wanted to show you this is because do you have to think in terms of radians all the time? No. You need to lay off in Marlboro Reds. That's another thing about the Joker. He was like inhaling and things. Woo! You think Sandra Bullock was bad on 28 Days? Man, he was inhaling those things. So some of y'all that like in the Marlboro Club, y'all might enjoy that. But, whoo!
just all.
What?
I just said we should start a Marlboro Club at Clemson.
No, don't worry. Pendleton's got you covered. There used to be people up there, in order to join Tri-County Tech, in order to be admitted, you had to smoke at least 2 packs a day. My God. Okay, let's find the exact value. Well, what are they doing here? They're going in reverse. They're going cosine, cosine, minus, so you know it's going to be sine, cosine plus, because this is minus, that's going to be cosine of 87, and of course that's 180, and that's -1. Now I like to do these on the test because they make y'all think what? In reverse.
In reverse.
Which is hard for some of y'all that can't spell race car backwards. Those are the same people that give them 6 cents at the cash register, the head explodes.
Yeah.
Yeah, it's $9.56. Here's 6 cents. About that. Oh yeah, I shut down the Highway 81. This was several years ago when it was just a regular McDonald's. Now it's one of those cafe type McDonald's. But back when it was just a regular McDonald's, I stopped by there one time before I was going to Greenville, and I had Einstein at the cash register. This guy was dumb as a box of rocks, and I gave him 6 cents. He wrote, and it would come up to be $6.56, and I gave him 56 cents. I gave him a $10 bill and 56 cents. And he had to call the manager because he had typed it into and he didn't know how much money to give me back. He looked at me like, "Are you going to tell me how much to?" I just looked at him. That ain't the fun. That ain't the manager came up there. He looked at me, and I looked at him like, I'm waiting for my change. He had to go in his office and get a calculator.
That's awful.
Write cosine of 180 minus theta as a trigonometric function of theta. This is where it says expressing cosine, replace A with 180 degrees, with B with theta. So do it. This is minus, so that's going to be cosine of 180 times cosine of 180 plus the sine of theta and sine of theta.
Sine 180.
See? That's what sine of 180, sine of theta. They're going to ask you to do these because you come out, the sine of theta cancels with that 0, and you're left with cosine. So in these cases, you're going to come out with a solution, and you didn't think you were going to come out with a solution. Oops, sorry. But this is a question on a test that people stare at. Why do they stare at it? Because there's no angle here. Well, angle don't matter because it's going to zero out down here. Don't worry. I don't know why that's... Oh. Here is your third function. Sine of A plus B. This time, what does the sines do? Do they match? Yes. Now, they don't match as far as it's not cosine, cosine, sine, sine. Now it's backwards. It's sine, cosine, and then cosine, sine. So that's how I remember it. And of course, the minus one. And I'm going to show you another way to remember these when we get through, another way to write them, and you might remember them a little bit better. So you don't have to write all this stuff. All you got to write down is sine of A plus B is equal to sine cosine plus cosine sine. Now the reason I don't say A and B is because I read from left to right, and I've been doing it for 53 years, and I also know that A comes before what? B. So if you want to spend the extra time trying to remember that, then that's good. But to memorize the identities or to have them in your head, it's easier to say sine of A plus B is equal to sine cosine plus cosine sine. And there is A minus B. Do they match? Yes, the signs match. Sine of A minus B is equal to sine cosine minus cosine sine. Those are two of the easiest ones to remember because you don't have to remember the conjugate or the opposite sign. So now you got 4. There they are. Plus, plus. Now the way they have these written is like this, and I want to show you. You may see them written like this. And I have to explain this because some of y'all go kind of berserk when y'all see this in general. you might see it written like that. And the first one would be the cosine. You might see it written like this, if I can remember it. Cosine of A plus or minus B is equal to sine, sine, cosine, cosine. Notice I'm not doing the A's and B's in my head. I'm memorizing. Now, what did we say with the cosine? If this is positive, this is going to be, if this is negative, this is going to be, y'all see how they're writing them? So you may see them written like that. And like I say, out of 30 students, when they look at that, 5 people are going to go, what's that? And they're going to look at it and stare at it for 15 minutes. Because some people don't get it. I'm not trying to make fun of anybody. I'm just talking in general. And here is your tangents. So go ahead and write those 2 down. I told you there was 6. Most of these questions can be plug and chug. I'd say 80% of 10.2 is plug and chug special angles, right in terms of radicals. The other 10% is, or 20% is going to be like that question, just solve, cancel out, and you're left with a cosine of 30 degrees or whatever the case may be. Now, let's look for the pattern. Do you see the pattern?
Yeah.
Well, plus, minus, minus, plus. So, if you was to write these, is everything else the same? Yes. So you can rewrite these as the tan of A plus or minus B is equal to, you notice everything's the same, so I'm going to write tan tan over, okay, I'll get to the plus or minus in just a minute, tan tan, 1 tan tan. Now that's pretty simple. Tan tan, 1 plus tan, 1 tan tan. Now, what happens when I have a plus here? What happens? The top one is the same, and the bottom one is what? Okay? What happens when it's a minus? It's the same, and what? So you can rewrite the tangent like that. So instead of learning 6, you only have to learn 3. You just have to learn the relationships between the signs, because the rest of it is tan tan, 1 tan tan. I'm not a big, as you know, I'm not a big regurgitation / memorization. I'm not big on that. I think it's important for you to learn it. But in these cases, in the reciprocals, do you have to memorize them? No. Do you have to not memorize them? No. You have to be very familiar with them. Does that make sense? In other words, you ought to be able to look at a sheet, which I tell you to print out, have it, and that way you can act like an index card. They need to be accessible like an index card of information. You shouldn't look at them and go, oh, I don't know how to use this. That's not what you should be. And you shouldn't spend the extra time memorizing it unless you just want to. Because by the time you get to Calc 1 and 2, you're going to have them down. Besides, by the time you get to Calc 2, by the time you go through Calc 1, you're going to have a lot of them down.
And we'll need these for calc.
Yep. You'll need them about 10% of the time, 20% of the time. 70% of calc is calculus. 70% of calculus is algebra. 20% is trig, identities and trig. 10% is actual calculus. Okay? All right, let's do these. Sine of 75, which will be what? 45 plus 30. Tangent of 7 pi over 12, I'm going to turn that into whatever degrees that is, and I'm just going to do it that way. After a while, if you do 5 or 6 of those problems, you're going to start relating the pi, the radians, to the degree, so that will come. And then, of course, that one, you're going to rewrite it, sine, cosine. Well, that looks like, you know, that's sine of A minus B. No yawning in class. I don't see how people drink cold coffee.
Good.
I can't drink regular coffee. I don't know why I'm drinking this. Yuck. I need to get some of that stuff, dang old Irish cream. Dang old, comes in a dang old.
Bailey's?
Yeah. Dang old alcohol. Throw a little bit of bourbon in there too. Dang old elf. Which I can't stand that movie because I can't stand Will Ferrell.
Oh.
That man creeps me out.
Really?
Yes, he creeps me out.
You do this one. This is Andy.
I don't know, I didn't do that one.
Okay.
How many of you have seen the little thing about the girl running into the glass window like 3 times? How dumb do you have to be to run into a glass window 3 times? Settle down, Pendleton. All right. So the sine of 75 is 40 plus 35.
Yeah.
I'm sorry, 45 plus 30. And that's going to be sine plus plus.
So you write like cosine X, cosine Y.
There you go.
Minus Y. Sine X, sine. You just use the idea. You don't have to put that.
Now, 7 pi over 12. Well, that's going to be 180. 6 will go into 12 2 times. 6 will go in 30. I'm just 30, 15 times 7. 225?
105.
105, okay. 105. That's good. So that means that's 105 is on the other side. So that's going to be what? 40. Yeah.
No, you have to do the whole thing. Like the whole I did in your hair. For just this one in this section, and then this one in this section. You're different.
Okay.
So 105. What is 105? This is tangent. Sorry. This is a tangent of 105 degrees. I'm going to take y'all's word for it. Let's see, 180, 12 will go in there, 6 will go in there twice, 30, 2, that'd be 15, 105. Tangent of 105, somebody give me, what is it, 60 plus what, 45?
Yep.
So that'd be the tangent of 60 plus, I don't know, forgot, 45. So that means, remember, tan, tan, 1 tan, tan. Tan, tan, 1 tan. And what goes here?
Plus,
Plus, and what goes here?
minus.
There you go. So tan of 60, tan of 45, 60, 45.
So what is this one?
Remember what I told you?
Is
A lot of
this-
times in trig, all you have to do is find out what? Where you're at. And that should be what you get. Now they use the conjugate. You should know how to use the conjugate. Conjugate of 1 minus the square root of 3 is what? 1 plus the square root of 3. You get shortcut number 3 right here, which is going to be 1, or 1 plus the square root of 3, 1 minus, okay, that's shortcut number 2. That's 1 plus, so I better do that one because some of y'all might. So that's going to be, down here, you get this shortcut number. This is shortcut number 2. So that's going to be 1 minus 3, which is equal to what? -2. And then up here, this is the square root of 3 plus 1, square root of 3 plus 1. That's the square root of 3 plus 1 quantity what? Squared, which is equal to a squared plus 2ab plus b squared. And that's going to be 4 plus 2 square root of 3 over -2, which is equal to what? -2 minus square root of 3. Now this is a good example. How much of this problem is new stuff? 20%. The rest of it's what? Algebra. Get used to this because that's what calculus is. 10 to 20% new stuff. The rest of it is algebra and a little bit of trig. We got it right. And you feel good about yourself. Okay, this is going to be what? Sine plus or minus? We know it's going to be sine of something. It's going to be sine of 40. Whatever. Sine of 40 minus 160. What I was going to try to show you is this. Where's my highlight? That tells you which one to use. It's going to be minus, so it's going to be sine of 40 minus 160, which is a sine of negative what? Sine of negative 120. What's the sine of negative 120? I hate them things. One of these days I'm going to get in and change it. Damn Ukrainians. Okay, so negative 120. Remember, what do? Try to find where you are. Where is negative 120? Well, negative 120 is down here. Right here. Now, what angle is that? Well, that's 90 plus what? 30 degrees. So you know you got 30 degrees, which is 2 what? If you go around this way, what is it? You said it.
240.
240. So 240 is 80, 180 plus what? 60. So either way you get it, you come up with a 60-degree angle. So 60 degrees is what? Now you can remember all students take what? Calculus. You want the sine. Down here, the sine is going to be what? Negative. So your answer is going to be negative. And then, of course, you know it's a 60-degree angle. So that's going to be 1, square root of 3, 2. And we know that the sine Oscar had square root of 3 over 2. So your answer should be square root of 3 over 2. again, if you are trying to memorize all this stuff, it's going to be very complicated. But if you just take a little bit of memory and a little bit of learning, it's a whole lot easier. And you learn a whole lot more than regurgitation. No yawning in class. You need to get better sleep. Improve your sleeping habits. Write the function as an expression solving the function of, okay, this is where you're going to see something cancel out. So let's do it. I'm going to let y'all do these. You should be able to sine. Okay, you know it's going to be plus. And then the tangent, that's tan tan over 1 tan tan. It's going to be minus and plus. And you should see something cancel out. No sneezing in class either. You need to take medication when you're at home.
There's a wholesome question.
What?
That's what makes her sleepy.
Okay, well. Miss Payne, you need to settle down. Miss Payne's asleep. She said, I want to sleep.
Hey, I'm here.
You are you? Dang, you're the one. You still paying attention?
Heck yeah.
Yeah, Helen's all over the Facebook today.
Yep. So, I want to go to a show.
No, the director of Homeland Security went and did a speech and was heckled off the dadgum. So that's the way you do things. When you don't agree with somebody, you're supposed to heckle them. Our dadgum. We've got some people leading this country. They're losing. They've lost their damn mind. What?
I just threw my
Priority
pencil.
1 message coming in on.
You got it?
Yeah, thanks. Don't mind me.
Yeah, you're just from Minnesota.
Yeah, we can't help it. We just throw stuff all the time.
You just disagree with somebody, you just beat them up, right?
Yep, that's how we roll.
That's the way you roll, Jay. If you disagree with Pendleton, if you disagree with somebody, you just beat the hell out of them, okay?
Okay.
That's what gets me. Antifa is supposed to be anti-fascism. And what is it when if you don't agree with somebody, you beat the hell out of them? What's that called? I think it's called fascism, isn't it? They're too ignorant. They want to start a revolution. Hell, they can't even start a lawnmower. Anyway. No, I'm not going there. It's about like that kid. Y'all are seeing that commercial? You got to get kids doing more, and he calls his grandmother to get a grape soda. Yeah, that's who's starting Antifa and revolution. Idiots. There you go. Now notice sine plus plus plus. So all you do is now what's going to cancel?
The theta.
Well, that one don't count. I thought one of them was going to cancel.
That's where I was confused.
Okay, you just stop. Evidently, some of them don't cancel. All right, this one, that one. Okay, these are not going to. There it is. There's one that cancels. Okay, so sometimes you get them to cancel, sometimes you don't. It's not a big deal. If I give you out of 10.2, I probably out of 5 questions, 1 would be like this. The other 4 will be from the double angle identities. Now, if you really sucked at the special angles, you're going to really suck at this. So you need to make sure you know your special angles. Give you a minute to write that down. No, we're not going to do that. No, we're not ready for that yet. That's probably going to be the end of it. Yeah, we haven't
I have a 0 on
used
it.
cosine difference identity.
I have an idiot.
This is when you're given an x and a radian. Of course, 180 over pi, that's x minus 90. So cosine of 90, sine of 90. What's the cosine of 90? It should be 1, right?
Yeah.
And the sine of 90 is 0. So that term is going to what? Cancel out. Or I got it backwards, I'm sorry. Yeah, 0, 1 would be 1, yeah. Got it backwards. And that's sine. So that's a good test question. But I'm not going to ask you a word problem with these examples. You're not ready for that. Question.
Oh, wait.
I'm just going to ask you that part. No, I'm not going to ask those.
I guess it doesn't.
Okay, that's a tangent. That one you can plug and chug. But you're not going to get, this could be a test question, but you're not going to get a special angle. You're just going to get fractions. This is nothing but plug and chug. And you should be able to do this without a calculator. So if I give you A is equal to a fraction and B is equal to a fraction, you should be able to plug and chug, especially when I gave you tan. You know that's tan plus. And it says it in the example. Hold on. There it is. Sine of A, B. There we go. Sine of A plus B, tan of A plus B, and the quadrant of A plus B. I'm not going to worry about the quadrant. I just want you to be able to do A plus B and A minus B. Okay? And you know it's positive. You can go back. If the tangent is positive, all students take what? Calculus. You know it's going to be either the first or the third, but since AB is positive, you know that both of them are positive, so it's going to be the first quadrant. That's it. So out of 10.2, I want you to be able to know the, let me get out of this. I want you to know the 6 double angle identities and be able to plug and chug and make sure you can solve for 4 of them and make sure you can do the algebraic and cancel if needed on the last one. So you're talking about, if I give you 5 questions, 4 of them are going to come from the double angle identities and 1 of them is going to be like that one or like this one. Well, that one. So make sure you know how to do the double angle identities. Now the next section, which I'm not going to get into a lot, I'm just going to get into kind of like for you to look at, is 10.3. And I think this is the last section in this unit, right? Well, the calculator, you should be able to do those, but we'll go over those. This section,
Those calculator ones, the graphs, it's not taking it. I'll go through the practice, like the help me solve this. I'll get it perfectly right. I go to put it in the question and it's wrong every time.
Some of them are kind of goofy, especially with those graphing ones. So here is the double number identities. So we're just going to write these down, and I just want to show you what the test is going to entail. Okay, again, we're talking about identities. So if I give you 5 questions, some of these are going to be plug and chug, and we're going to do them, okay? So, other forms are they going to give us one? There we go. There is the double number identities. You're probably talking about 10% of the test coming out of 10.3. Not a lot. I want you to be able to use them, but I'm not going to, I can tell you right now, the double angle, the reciprocal, the Pythagorean, and the co-functions, those identities are going to make up probably 80% of your test. 10% will come from 10.3, and 10% will be graphing questions. So you're talking about 2 graphing questions, maybe 3. You're talking about 2 or 3 out of 10.2, and then or 10.3, and the rest of them, 20, will be out of 10.1 and 10.2. So most of you should be able to figure that out. Now, there's not really anything pattern here. So you probably going to have to write these up as memorize, or make sure you got them on your sheet. Okay? I'm not going to try to tell you there's a pattern here, because there's not. You have 3 cosine of 2a's. You got 3 choices for the cosine. You've got 1 choice for the sine and 1 choice for the tangent. Now you can use whatever you want to with the cosine, but you'll see in some cases you'll be able to tell which one to use. So the cosine of theta, which is equal to 3 over 5, and the sine of theta. Now you can do a little bit of thinking here, and I think it's important, and I hate to tell you this, I used to have a calc teacher who used to tell me the same thing. Where are you? Well, let's take this. All students take calculus. You know that cosine is what? Positive. So that means it's either in this quadrant or this quadrant. And it says that the sine is what? Negative or positive? So that means it's where? That means it's in the 3rd quadrant. It always helps to know where you are. Okay? So that's the first thing to do. Find out where you are. You're in the 3rd quadrant. Now hopefully everybody understands what I just did. I hope. And then to find, you must plug and chug. Okay, this is where, okay. I don't agree with this, and I'll tell you why. This is what I suggest you do with the problems here. I would just draw a 3rd quadrant, and I'm going to draw cosine. What is the cosine? Oscar had a what? You know that the 5 is what? Positive. You know that the A is what? Positive. So therefore, you know that the opposite is what? Negative. So now we use the Pythagorean theorem. 3 squared plus A squared, or O squared, whatever you want to call it, is equal to 5 squared. O squared is equal to 5 squared minus 3 squared. O is equal to the square root of 25 minus 9. O is equal to the square root of 16, which is what? So we know, and now you can find whatever you need to find, all right? And that's what they're doing with the Pythagorean identities. You don't have to do it with the Pythagorean identities. Now watch. When I go through and do it, they're going to use the Pythagorean, and that's fine. But watch what they get. Okay? What is the sign if we use this right here? What is the sign? Negative what? Oscar had negative 4/5. So you're going to get the same answer whether you use the Pythagorean identity or whether you use the Pythagorean formula based on all students take calculus. Capiche? Hopefully you understand that. All right? So the sine of 2 theta is equal to the 2 sine theta, so I'm going to plug in negative 4/5. And what is my cosine? 3/5. So I'm going to plug it in here. I'm going to plug in negative 4/5 and 3/5. And that's it. Now, if I was to pick a problem out of 10.3 to put on a test, it would be one like this. Why? Because it has everything in it. It has Unit 1 and Unit 2 in it. The reason I like to do the Pythagorean formula is because what do you know better, the Pythagorean formula or the Pythagorean identities? You know the Pythagorean formula because you've been doing it for the last 2 years. Whether you had Algebra 2 or whether you had Pre-Cal and now. So you're used to it. So that's what I tell students to do, and it falls right in line with finding out where you are. When you find out where you are, you can set up your triangle. And that comes quicker to everybody. So, how are you going to do the cosine? Well, plug and chug. There's your cosine. Once you find the sine and the cosine and the tangent, you're what? You're done. Well, what's the tangent? Well, the tangent, what is the tangent, folks? You got your, what is it? It looks like that. We said this was 5, we said this was 3, and this is -4. So what is your tangent? Oscar had a hunk of apple, -4/3. So when we do the tangent, we're going to plug in 4/3, -4/3. All students take calculus. The only thing that's positive is the cosine and the what? The secant. So that means tangent's going to be negative. So when we do the tangent, instead of cosine and sine, we're going to plug in the -4/3. There we go. Okay, we have to. They use the reciprocal identity. You don't have to do that, but okay. So that's -24/25 over. See, that's the sine of 2 theta over the cosine of 2 theta. They did it a little bit different, which you can do that.
Can you explain where the -24/25 came from?
That came from the first part.
Yeah.
We found the sine of 2 theta. Let's go back. The sine of 2 theta. You just plugged and chugged. Oops.
So I got where we got like the -4, but then I was confused.
Okay, right here. Sine of 2 theta is equal to 2 sine. There's where the 4/5 comes from, -4/5. And then the cosine is 3/5. You're just plugging and chugging.
Okay.
And 2 times 4 is 8, times 3 is 24, 5 times 5 is 25. Now you're going to use that, and then you're going to find the cosine of 2 theta.
Sure.
There's the cosine of 2 theta. And once you have the cosine of 2 theta and the sine of 2 theta, you just use the reciprocal identity to find it. Now let me go back. Could I use this? Yes, I could use this. What would you plug in? Well, what did I tell you we had? 4/3? Was it 4/3? -4/3? Somebody help me out.
Yeah, I think it's negative.
Yes.
So -2 times -4/3 over 1 minus -4/3 what? Squared. And that's going to give me negative what? 8/3 divided by, well, let's go ahead and do this. What's -4/3 squared? That's 16 over what? 9? So 16, let's change that to a blue. Change this to 16 over 16 minus, 9, just give me a second. Change that to a 9 over 9. 9 over 9. Okay, what's 9 minus 16? I heard somebody mumble -7. Correct? Somebody check me on that. -4 times -4 is 16. 3 times 3 is 9. So I got to change my 1 to 9 over 9. 9 minus 16 should be -7. Multiply by the what? Reciprocal. That's a negative. And we can cancel, use our red marker. We'll cancel that 3 here. What's 8 times 3? 24 over 7. I don't know what they got for their tangent. What did they get? I don't know if they got that or not. You should be able to get the same thing. I did multiply everything correctly, I hope. Let's go back. What did they get for the tangent? It's a miracle. What did I just do? I just used a different form, and I what? I plugged and chugged, and what did I get? I got the same what? Let me give you an example. Y'all think we don't use this in real life? I'm going to give you a quick example. What is this? Well, it's really not.
I have no clue. Is it a phone?
That's one of those old cell phones. You remember them cell phones that we used to have? And then we went to one of these phones. Remember the StarTax?
Oh.
And then we got down to what? Now we've got a smartphone that does what? That of a computer. Don't tell me we don't use math in real life. What does this do? Does this do the same thing that this does? This weighed about 5 pounds. This slips in your pocket. How many examples can you make? What about the TV that some of y'all grew up with? I grew up with a TV. Guess who the remote control was? Me. Okay? Hubert, turn that channel 13. We only had government TV. All right? That's G-U-V-M-E-N-T, government. We only had 13, 4, and 7. And we had to switch it, and I had to switch it in one of those big knobs that you turn. Okay? Now, and it looked like a big what? It looked like a bar. I mean, it was a big old TV. Now, look at these screens y'all got on your... But we don't use math in real life. All right. I'm going to count everybody here because I don't feel like doing the roll. So I'm going to go ahead and cut it off. Y'all can work on now 2 point, 2 point. 10-1, 10-2, 10-3.